Hello everyone, my name is Antonio Coleman and it is my pleasure to welcome you back to my ongoing video series. In this video series, I will be covering various data structures and algorithms within computer science, and more specifically, object-oriented programming, with the main language being C++. In my last few videos, I covered various concepts within BST, red-black trees, including some of the more theoretical components, like the definition of the acronym BST, which stands for Binary Search Tree, as well as the common examples of applications where red-black trees are preferably ideal. One of the examples that I covered will actually be the main focus of this video. If you don't remember, there is no worries at all, as the program that I talked about was a spell checker. For reference, this is not a video where I will be doing a live demo where we code together. While this may be unfortunate news for some, the importance on why I made this decision is very clear and purposeful. That being, while coding live can help you understand how to take code that you may not understand and just cram out a project, instead I previously coded out a program broken down into a .h for my header, as well as a CPP file which will store most of the source code, and lastly a test file as well, which will cover and store things like my test cases. Additionally, I would like to share that I chose to hardcode the input and output just for convenience in this video. However, if you want to make this a full stack or more user-based application, this is definitely not the best practice, and I want to reiterate on that and specify ahead of time. Furthermore, while you may question why I made this decision, it is clear as well. This video will cover some basic layers of how to structure a project, offering you some visualization on how to create a program using red-black trees, as well as later on expand on the differences between hard code and more dynamic code, which I will make a video on in the future. Additionally, it is important to note that this is a more preferable methodology long term, but for the purpose of this video, let's get into some code. For the .h file, some important points of emphasis include my header guard, which helps to ensure the contents of my file are only included once. Additionally, the node structure is also the most important part of this file, and this is because it helps work as a building block for everything else, as the color red or black along with pointers allow for the structure for my left, right, and parent nodes. Also, I have a default constructor as well as destructor in my public, as well as the insert operator, which adds a new word from the dictionary, as well as my private helpers like destroy tree, fix insert, and insert recursive, which are all essential to help the red-black tree balancing function stay effective. Now let's move on to the next slide, which covers a snippet from my source code. In this file, some important points of emphasis would be, first, my insertion logic. An example of this can be found in the function insert recursive, which helps to find the correct location and create a new node, which handles the root case, but also leaves my red-black tree as an empty stub, which is important to maintain its properties. Also, I have search logic through the contain function. This helps implement a ologn search by traversing the tree based on string comparison until the lowercase word is found or a null pointer is hit effectively. Lastly, let's move on to my test file. Some important things to note about this file specifically is that it creates test cases to validate the logic of the project, such as loading up the dictionary, punctuation, and also capitalization. For perspective, I chose to add an emphasis in this project primarily using lowercase letters deliberately. This is because while it is not mandatory to do, I personally chose to make this decision during design so that all words that are spewed out maximize readability at all times and also can help and aid and assist in debugging. This is because if I ever run into any compiler issues or wanted to further iterate on the project, lowercase letters will provide a clear advantage in terms of catching pitfalls that may occur during testing due to mixed combinations of letters. An example of this can look something like mistaking an uppercase I with a lowercase l. However, now we have come to the conclusion of the video. I hope you found this video concept as not only informative, but also a nice balance from just standalone slides. And furthermore, I cannot wait until my next installment, where I will prioritize an opportunity for you to join me and code along during the process throughout. Thank you,